Welcome back to STEM Online Academy. My name is Jason Masterakos. I am the founder of STEM Online. Okay. Today we're going to get right into it. We're going to talk about specifically the calculus mistake that makes hard problems feel impossible. Yes, that's right. Uh, let's get right into it. Right. What do I mean by the mistake that makes hard problems feel impossible? Okay. Well, uh, as you all know, mathematics can sometimes be scary, okay? But it's the way we approach it, right? Mathematics is not about formulas, it's about understanding, okay? And some of the questions I'm going to be discussing in this video is going to make a lot more sense by what I mean by that, right? So, question one is, why does memorizing a formula work for an easy problem, right? For an easy problem, but then it fails for the hard problem, okay? That's the first thing we're going to answer. That's the first question, right? Second question, right, is, let me think about this one. Yes, why does a derivative, what does a derivative actually mean? My mistake. What does a derivative actually mean? Okay, I think most of you can articulate that, but if you can't articulate, you may, not always, may not understand. Okay. Number three, what does an integral actually accumulate? Right? What does it accumulate? Right? Question four will be, what does a limit actually compare? Okay. And then question five, right? Finally, we'll say, the question is, let me think. Why can two students use the same formula, but only one understands the actual problem? Right? So two students using the same formula, but one actually understands the problem. Right? I mean, both students can get to the right answer, but that's not good enough because maybe one student did it by luck. Do you truly conceptually understand what is going on? That's the main point. Okay. If not, then it's problematic. Okay. So let's think about that, right? So for question one, I want you guys to sort of think about it for yourself for a moment. Okay. All right. Talking about why does memorizing a formula work on an easy problem as opposed to a hard problem? Okay, why is that the case? Come on, I'm sure you guys must know. Why is that the case? Okay, why is that the case that for the easy problems it works, hard problems you need much more than that? Because hard problems you actually need to set up a logical plan of attack. Okay, you can't just say, okay, I have the formula and then start using it. And you probably already intuitively know this, right? Uh, you probably came across problems, either word problems or tangent line problems or optimization problems or accumulation problems, doesn't matter what it is. And you notice that, okay, I have this formula, but you'll notice that even a person who's bad at math will be able to understand that the formula, it doesn't work because there's certain constraints and parameters that need to be taken place in order for you to use that formula. Quite often in the hard problems, it doesn't work that way, right? You won't have all the known variables in order to use the formula. It would be impossible. Or there'll be something else. You may need to manipulate that formula into some other form. It's not always straightforward. Okay. And looking at the second video that I have on the screen, I talk a bit about that, right? So what I'm talking about is showing you what's important, right? Okay, so if you look at the video, right? Look at the video here. So when it comes to the hard problem, right? The formula, see what I said about the formula, right? Formulas, okay, yes, they're good, but you need to have a plan of attack, though. You need to have some sort of strategy, okay? Otherwise, you're just guessing. That's not the way to think of it. Okay. So the reason why it fails on hard problems, why formulas fail on hard problems, is because you need to have a structured problem solving way of attacking a truly hard mathematical problem. Okay. All right. And it depends what that is. Everyone has a strategy that they use. For those of you who don't know, I use mine, which is the visualize. Step one, visualize. Step two is to model the problem. Step three is to execute. The execution part is somewhat easy. It's the algebraic part of any problem. Okay. And then step four is you want to verify, right? Verify can mean a number of things. Maybe you have to show that an equation, the left-hand side equals the right-hand side. In other words, you need to prove that it's correct, right? By verifying it. There could be a number of other things as well, right? But verification is very important. Okay. All right. So that's the reason why it fails. Now, for question two, what does a derivative actually mean? Okay. Now, I know this would be something that is obvious, but it's not that obvious even to the most elementary calculus student. Okay. Even though your teacher more likely should have talked about it. If they didn't, they're doing something wrong. Okay. They sort of discussed what a derivative actually is. All right. And the derivative is actually, okay, this is what a derivative is, right? It's finding the slope, right? Not the slope of the tangent line. Not, now be careful. You have to be careful this, right? I'm going to rephrase it actually. I have to be careful myself. The slope, right? The slope of the function, right? The slope of the original function that you have, let's say y equals f of x, taking the first derivative of that, the y prime, is getting the slope of the function of x, right? Slope of the function of x. And that is it, right? Slope as a function of x, right? Now, the slope of the tangent line, right, would have been the slope of the function of x at x equals some number, right? At x equals a specific instantaneous point where the tangent line hits the curve, right? That would be the slope of the tangent line, okay? So that's what a derivative is. Okay, in other words, slope of a tangent line as a function of x, or in other words, the instantaneous rate of change. Okay, I hope I'm making you guys feel more at ease and less nervous about calculus. Okay, all right, because quite often I feel like calculus has been presented as some sort of a nightmarish scenario. It is one of the hardest areas of math. Even for abstract math, it's one of the hardest, at least in undergraduate mathematics, right? One of the hardest, not hardest, but one of the hardest. Okay, there's harder stuff. Trust me. Yeah, it's really scary, but I'm not going to go into that, right? But yeah, there's harder stuff. But yeah, that's for another video. By the way, if you want me to discuss interesting interesting math topic, hopefully it's related to advanced math and physics, I can always talk about. You can put it in the chat. Actually, that'll be interesting. If someone can put that in the chat, the YouTube video below, and say, okay, I want you to discuss this sometime, either because I'm an independent learner, I like to learn things, or it's for school, right? So either way, that'll be great if you can put in the chat. All right. So question number three, what does an integral actually accumulate, right? What's the point of the integral? What does it mean by it's accumulating something? Okay, what does it mean that it's accumulating something? So what I mean by accumulation is, right, you should know that you are visualizing, let's say you have a curve, y equals f of x. Let's say you have the right part of a parabolic curve, okay? On the right branch of a parabolic curve, you have y equals f of x. So it intersects at 0, 0 and goes up the right branch, okay? Now, under that right branch, right, from 0, 0, from coordinates 0, 0, all the way going on into infinitum to the right end part of the parabola, visualize that you have some sort of rectangles, right? Oh, well, let's say rectangles. So you have trapezoids. Because the integral was actually a limit of a Riemann sum, right? The Riemann integral. And the Riemann integral, you can say a Riemann integral. Riemann integral, you can say it's some sort of trapezoidal, a trapezoidal rule. So by trapezoidal rule or a Riemann sum can approximate what an integral is. Okay. So if you are to calculate using the trapezoidal rule, what you would have visually underneath that parabolic curve on the right branch from 0, 0 all the way to infinitum is you will have, n number, depending what n has been defined as, n arbitrary numbers of trapezoids under the curve. Okay, we sum them up, right? And that's supposed to represent an area accumulation, right? We sum up the area of the trapezoids under the curve, sum up the areas of the trapezoids under the curve, right? And that is that's our integral, and that integral represents the total area under the curve. Okay, this is one way of defining it. That's the way I've articulated what what accumulation is, right? Relating accumulation to integration to area. Okay. By the way, if you're not understanding something or you need more of a visual aid, as you can see in my simulation here, I talk about visualizing. So maybe try drawing what I'm saying down to you, right? Like what I'm saying from words, try to visualize it, right? Because if you visualize it, it can help in the conceptualization. Okay, so try to visually conceptualize what is going on, right? And then you want, that's step one. Then you want to model. What I mean by model for step two, I mean create a semantic map of what's important, right, for any problem, right? What is known, what is unknown, some sort of strategy from the visualization. Maybe you need to not only what's known and unknown, sometimes we can assign quantities when it comes to hard problems. So quantities help. Quantities to the visualization. And then step three, you want to be able to execute, because once you have in terms of quantities and variables, then you know mathematically you can extract some sort of equation, hopefully. It's not always easy. There's been times when I've had difficulty myself, actually, right? Yeah, it's not always straightforward. It's tricky. Sometimes very tricky. Okay. It's something that requires a lot of practice. A lot of practice. Okay. I'm not going to sell you something that is straightforward, like a one formula hits all type of solution. No. Even though my strategy can help, you still need to do the work. You still need to do a lot of problems, right? Right? You have to attack a lot of problems. Okay? And that will help you get better at mathematics in general. Okay. Also, question 4, what does a limit actually do? What does a limit actually do, and what does it compare? A limit, right? If you know what a limit is, a limit as x approaches a of a function of x, which is equal to limit L, right? L is defined as the limit. Okay. What's the definition of a limit? Well, I talked about the definition, but not in more detail. Okay. I won't talk about epsilon delta. No. That's for another video. And that's getting a bit complicated. But I mean, graphically, what does the limit do? The limit, right? If you have some curve, okay, you have a curve, right? Let's say y equals f of x, some curve. And in order for the limit to exist, the limit as x approaches a of f of x equals L. In order for that to exist, there needs to be a left-hand limit as x approaches a from the left of a function of x, and the limit as x approaches a of f, from the right of f of x. If both left-hand and right-hand limits are the same, That means they're equal. And then that means that the actual limit as x approaches a of f of x is equal to L. Okay? That only works if the left-hand and right-hand limits are the same. Okay? Now, you may be thinking, how do you know that they're the same? How do you know they're the same? Well, that's going to depend, if you have a continuity or discontinuity, a jump discontinuity, or of some sort or whatever, right? If you have a hole and you have a circular dot or whatever, depending where they are on the graphs, right? The positions on the graphs will tell you if at that point at x approaches a, depending what your a is, maybe it's 1, 2, 3, whatever it is. X approaches 1 from the right, x approaches 1 from the left. If their limits are the same, exactly the same, then the actual limit as x approaches 1 exists. Okay. All right. So that's what you need to understand when it comes to limits. What do they compare? All right. And then finally, this is a very important question that nobody actually bothers to think about. Okay. Why can two students actually use the same, use the same formula, but only one truly understands the problem? Now, the formula, here's the problem. I'll tell you why. Because the formula, okay, you can have two students do this exactly same problem, get exactly to the same answer, okay, but only one truly understands how to do it, okay? And the reason for that is because what that proves is that the formula doesn't test understanding. It doesn't. It doesn't test foundational understanding, okay? If you've been told that, you've been told a lie that somehow it tests understanding. No, formula doesn't. Okay. Unfortunately, sorry to burst your bubble. All right. The formula is just, it's, I guess you can say in school, it's a way to see if you can actually, manipulate something basic and do procedural type of thinking. But it does not test understanding or foundational thinking whatsoever, right? Because as I said, you can have two students do exactly the same problem, use exactly the same formula, get to the same answer. And if you ask both of them, right, if you ask both of them how you came to that answer, one student will be able to articulate very well, the other one won't, right? The one that doesn't know how they went about it, they clearly don't conceptually understand it, okay? Now, why is this important? Because a lot of times, especially if you're going to university, if you're that high school student that's going to university, and then you're used to this type of procedural way of doing math, okay? And that's going to give you a problem, okay? You need to become used to a new type of way of thinking, something called problem solving, okay? Which is independent of any type of algorithmic approach or procedural approach to doing mathematics, okay? Right. So I hope this video made a lot of sense to you guys. Okay, hope it brought some type of value, right? So yes, for those of you who are new, like and subscribe. I really appreciate it. You help STEM Online grow. And for those of you who already are subscribers, thanks again. It's without you, this channel probably won't survive. But yes, for new viewers, please like and subscribe. It helps the channel a lot. Okay, it's right. It's something that I like to share. I like to share, and I like to help you guys try to figure out your mathematical journey from the end of high school to end of third year university, right? Because that's what I specialize in. Okay. And remember, as I said, right? If you have any questions, put them in the chat below for this YouTube video. I am going to do next week. I'm going to be more I'm going to try to be more consistent. I'm going to try to do three videos. I think this week I did two. I'm going to do more of that. And as I said, right, another thing that's important too is that the fall semester is coming, right? Again, the fall semester is coming. So that means back to school, right? So if you're if you're in high school or you're high school going to university, right? University bound, uh, you may need or are looking, parent or student, looking for someone to guide you on your university journey. STEM Online is here to help. Again, we're a coaching company, right? That specializes in advanced mathematics and physics for students who need help tackling, uh, you know, hard midterm and final exam problems. Okay, right. So again, uh, and our services are very reasonable. We charge reasonable prices. You can find more in the description, in the link below. There'll be a link to my services, all my services there, depending what grade or what year of university you're in. Okay. So again, that is it. Thanks again, guys. Like and subscribe. And again, STEM Online Academy is about understanding and problem solving, right? Not formulas, not procedures. Thanks again, guys, and have a very good weekend. Bye bye.